So if you require, I'll pitch in. If you don't require me, I will be on mute. Okay. Welcome, guys. To the deep learning webinar. So we will be starting the session in a couple of minutes. So we'll wait for another 5 minutes, like all the participants to join. From there, I think we can take it forward. Yeah. So maybe I think you can share your screen, sir.
Yeah, sure.
Because people may not understand whether this, they have joined the right webinar or not. Maybe you can go to the previous slide, sir. First slide. Hey, hi Archana, good evening. Hi Subramani, good evening. We are there in the webinar. We are just waiting for the other participants to join. So that's maybe around 5 exactly, we will start the webinar. So until then, maybe we'll wait for some time. We'll give a 5 minutes time so the other participants also can join. Pragya says she can't hear anything. Pragya, is other people also finding the same problem? I'm Rityunjay. Smita, I don't think anyone is speaking. Smita, we started speaking now. Raghu sir, you're able to hear me, right?
Yeah, I'm able to hear you. Yeah.
Okay. A lot of people are confirming that they're able to hear. Okay, please check your system's configuration, especially on the audio side. Yes. So a lot of people are able to hear. Great. Thanks for the confirmation. Great. So we are getting confirmation still. So few people are not able to hear still. So they have to check their system configuration. Otherwise, I think most of the people are able to hear us. Another 2 minutes, guys. We'll be starting the webinar. Yes. Somebody says reconnect. So basically what I mean, see, there is a reconnect button on the top. You can just click on the reconnect button, automatically refresh, so that if any issues, whether it's, if it is getting freeze, the screen is getting freeze for you, or you are not able to hear, you can use the reconnect button. Right. So yeah. So Rakesh, don't worry about the screen. The screen has not been shared. So before sharing the screen, the screen is shared, but there's not showcasing any slides or anything. That's why you're finding it. Yeah. I think now we have shared screen. Okay. I think we are almost nearing to 5:05. So we will be starting. So sir, maybe you can start with your introduction. By then, I think we'll have more participants joining in. Just before that, there is a person asking for the recordings. So guys, we will be recording this session, and also you will be receiving emails of the recording. Once the session is over, you'll be receiving the recordings also. Okay.
Okay.
So,
Yeah.
right, I think we can
Great.
start the webinar. So Raghu sir, you can take over from here. Over to you, sir.
Yeah. Thanks. So thanks for all the participants for joining the series of webinar on the advanced machine learning. In this webinar, we will be talking about what is called as deep learning. And as today is the first day of the webinar, I will be starting with the basics, so that if you don't have attended previous webinars or anything, it would be fine, so that you can get started afresh. So myself, Raghu Prasad Konandur, I work as a subject matter expert for SkillUpRight, and I have overall 24 years of experience in the IT, and I work with multiple projects, and from last 5 years I'm into machine learning, artificial intelligence. So also I consult for many projects and for many companies on these things. And why I work pretty much on various technologies. I started my career as a Java developer and all the way moved to solution architect. And then I got the opportunity to work with various technologies, like I work with Python and then machine learning, artificial intelligence. And also I work with test automation, Internet of Things. So pretty much on multiple technologies I work. So this is where actually from the last 4 years I got interest in machine learning, and which was emerging at that particular time. So that's where I give webinar as a subject matter expert at various forms. So thanks to SkillUpRight for providing us an opportunity to interact, providing me an opportunity to interact with you people. Okay, so with that brief introduction, let me just go through the agenda for today's session. So this session is for 1 hour, and I will start with introduction to artificial intelligence, and what exactly is the artificial intelligence, and what kinds of application we can develop with artificial intelligence, and as a participants, why you should learn AI, so how it would be beneficial for you. And specifically I will be today talking about the neural network. So that is what is the topic for today, and then I will be just demonstrating the hands-on on using the neural network. Okay, so that's what is pretty much agenda for today's session. So let me start with, and with the prerequisite for this is with the assumption that few of you already know Python. So because this we are artificial intelligence or neural network, the code base is built on Python. So it would be great if you already know Python. If you don't know Python also, that would be fine. But as we will be starting with the neural network, so we won't be touching on the basics of the Python. But that won't be much difficult to understand at the conceptual level. So there won't be much problem to understand the concept. Okay. So with that, when it comes to artificial intelligence, so now everyone is talking about artificial intelligence, machine learning, deep learning, and all those things. So what is this exactly, and how each one of them is different from each other? So basically, we call artificial intelligence the if a machine can demonstrate the intelligence of a human being, we call that as the artificial intelligence, because as a human being we have the great brain, which gives us the natural intelligence, and with that we have ability, we do these cognitive functions. We can think, we can solve some problem, we can learn, so we can do a lot of things with our mind, right? So is it possible to make a machine think like a human being, work like a human being, act like a human being? So that is what we wanted to do, because we want to make our life much better, much easier. So if is it possible for a machine to think and act and then behave like a human being? In general, this particular science branch of the science is known as the artificial intelligence or machine intelligence. So Now coming to the machine intelligence, so many terminology like we use quite often. One of them is the AI, another one is the machine learning, another one is the deep learning. So is there any difference between them and how they work together and things like that? So in broad category, we call it as artificial intelligence, which is nothing but any technique that enables computers to mimic the human intelligence. So as human intelligence means we have the ability to think, we have the ability to take some decisions, right? So those kind of things can a machine do without exactly explicitly being programmed for a particular situation. Okay, so that is what we call it as the artificial intelligence. The subset of the artificial intelligence is machine learning. So overall it is artificial intelligence where where machine can mimic the human intelligence. That is what we call it as an artificial intelligence. The one of the branch of the artificial intelligence is the, or a subset is the machine learning. So machine learning, here we use different statistical techniques which enables the machine to improve at the task with the experience. Like say, as a human being, if we do the same task many a times, right, then what we obviously we will be improving on the execution of that particular task, right? So in the similar way, like this is one of the machine learning is, once we apply some of the statistical techniques, the machine will improve the performance of the particular task with the experience. So that is what we call it as the machine learning. So one of the subset of again machine learning, we call it as the deep learning. So where here again our main intention is to improve at the task with the experience in the same way, but the way we approach the task or way we solve the problem is somewhat linked to the way our brain works. Okay, so brain has so many crores of neurons, right? So our brain is a very complex system. It has crores of neurons which work together to do anything. Like let us say if we look at a traffic and suddenly some vehicle comes approaches us with very high speed, then naturally we will step back, right? So that means what? So it is not just one impulse which is moved from your eyes to the brain. It is not so. It involves so many crores of neurons which work together, and it will instruct finally your legs to move back, right? So this way the human brain is a complex system. Can we somewhat try to get the understanding of the human brain, and can we use the way human brain works to solve some kind of a problem? That is what we call it as the deep learning. Okay, so deep learning is the subset of the machine learning composed of, again we will be having algorithms that that permits the software to train itself to perform the task. What kind of task we can do here? It could be image recognition, it could be speech recognition. Okay, so or some kind of data analysis with the textual data, right? So these kind of things by using what is called as the multi-layer neural networks. Okay, so that is what we try to solve a problem in deep learning by simulating the way human brain works using what is called as a neural network. So that is what exactly is the deep learning. So in broad term, it is artificial intelligence. Anything which a machine can mimic the human intelligence broadly is called as artificial intelligence. In that you have a machine learning where the task is given to a machine, it improves with the experience, the way we human being performs the task. And the other subset is using the multi-layered neural network to solve the problem. That is what is called as the deep learning. So today we will be discussing in detail about what is called as the deep learning. So what are the different ways artificial intelligence can be used. One of the ways where we use machine learning, and in that again we have classification like supervised machine learning, unsupervised machine learning, and then we have deep learning, reinforcement learning, and deep learning. So machine learning is like, can a machine can learn by itself? The question is like, as a kid, how we learn to remember some of the images, or how we learn to start talking, how we learn start walking. So it is nothing but we learn, right? As a human being, we learn. So how we learn? Again, sometimes someone has trained us. That is what we call it as the supervised learning. In case of the supervised learning, you see, maybe our parents should have shown the images of so many fruits or toys or something, and they asked us to remember those things, the image as well as the name of that particular image. So that is how we learned, right? So that is what we call it as the supervised machine learning, wherein which we are able to we are able to understand the things with under the supervision of our parents at that particular time. So where they showed the various images and they told us, okay, this is A for apple, B for ball, or anything like that. And then if they showed a different image, maybe a bigger ball or maybe a different color ball, still our brain is able to identify, yeah, it is a ball. So that is what we call it as the supervised machine learning. And then we had this unsupervised machine learning, where exactly there is no supervision here. It is something like, suppose if new set of fruits are collected, which you have not at all seen in the beginning as a kid. So still you want to group them based on the shape or size or anything like that. That is what we call it as the unsupervised machine learning, where there is no label data. We don't know, okay, this fruit means this. There is no label data, but we want to segment and we want to create a group. That is what we call it as the unsupervised machine learning, right? And we had this deep learning where we are going to use this multi-neural network to solve a problem, and that is one of the. Other than this, other areas where a lot of things are happening is the natural language processing, right? So not natural language processing. Like as a human being, we are good at reading, writing, and all those things. How about a machine? Can a machine can understand what we type? Right. That is where we are using the chatbots nowadays. So you can interact with the machine. So maybe when you make a call for any service, it is maybe answered by a machine, not by a human being. That is what is natural language processing. It will try to understand the context in which you are talking to the other end, right? Suppose there is a problem in your laptop or there is a problem in your network. So the moment you start interacting with a chatbot, you start talking to it. So it will understand what is the context, and then it will try to give you a solution, or it will further escalate. So those kind of things are the natural language processing, the way we start talking. One of the example is like when you start replying to Google Mail, Gmail, right? So automatically it prompts for a statement. So that is again natural language processing. This may be content extraction, classification, machine translation, question answering, text generation. So these are all again the branches of artificial intelligence. That is one of them is the natural language processing, or NLP. Another important aspect is the vision, like the way we have eye. Similarly, a machine can have its own vision with the help of a camera. It can detect the image, right? It can recognize the image, and it should be able to identify some intruders or things like that. It could be facial recognition, it could be any other thing. So that is what, or recognizing the image of a medical record, right? That is also image recognition. That is one of the things. Other than that, speech to text, text to speech, it is there in the Google. You have a lot of things like speech to text conversion or text to speech conversion is there. And other than this, robotics is one of the area where artificial intelligence is used. And also some of the systems are built specific to a particular solving some particular problem that we call it as the expert system. So a lot of things are happening in this area, artificial intelligence. Okay, so these are the few of them. So what are the possible applications of artificial intelligence? As I already told you, it could be like image analysis, it could be audio analysis, it could be visualization or virtual personal assistants, right? Now we have Amazon Alexa or Cortana or Google Assist. They're all virtual assistants, or natural language processing, the way we speak with the chatbot or anything. And simulation modeling in the scientific community, like a lot of simulation happens, a lot of modeling happens, and machine translation and social media network analysis. There's a lot of things are happening nowadays in the social media, so analyzing that social media. So a lot of inputs are required, especially now currently at this position what we are in, right? And robotics, that is one of the area. And ultimately a human being want a self-driven car, someone has to drive for himself, right? That is again an example of the artificial intelligence. So there are a lot of such possible applications of artificial intelligence. Now the question comes, why deep learning, or why is it becoming popular? Why it was not so in last 5 years or 10 years? Why is this it is becoming popular? So now because of the explosion of the internet, because of the availability of the internet to most of the humankind, so huge data is being generated by the human being, right? So every day when as we talk, as we speak, when we blog something, when we create a blog, or when we chat, or when we upload some things into the social media, or we post something into the social media, we are creating lot of data, right? So there is a growth in the data, and the companies wants to know exactly like what people are talking about their services, what is that, how they can make use of that data to reach to the customers, right? They want to give a better service. So that's why as the data is growing, they want to understand the impact of hidden truth under that particular data. If someone is talking good or bad about their company, their services, their products, they want to know. That is one of the things. At the same time, second thing is there is an advancement in the hardware, right? So there is an advancement in the hardware. So currently you have very good processors you have, and which was not there, and also it is coming at a quite cheaper rate compared to 5 years ago, right? And if not, you don't have hardware also, no problem, you can work in a cloud, right? So that is what cloud and AI boom is there. So there is a lot of possibility for anyone to explore, experiment, right? So you can burn your hands, or you can make your hands dirty by exploring. So that is what is the reason of growth of the applications on the artificial intelligence. And other thing is like languages like Python, which is a generic language, and also it is an open source, and there is an ecosystem is built on top of Python to solve problems in data science, machine learning, artificial intelligence. So as it is an open source community, people started contributing to it. People started contributing to it. A lot of open source libraries available, a lot of communities available where you can interact with them and try to work on take some particular problem and solve it. Okay, that's the reason. And as a participant of this particular webinar, why it is very important for you? So I feel like maybe now or maybe down the line, so definitely whichever the company you are working in, so they want to use these techniques like artificial and machine learning into most of their products or services. So maybe this is the right time for you to invest, to learn the new techniques, so that you become really competitive. Because as per some of the survey, so most of the work what we are doing now, that may not be there 2 years down the line or 5 years down the line. So we have to switch to the latest things happening. So that's why it is very important for you people to learn and understand these technologies, which is emerging technologies, right? So that is where very important. And how to get started? The first thing you should at least learn one of the programming language. At this point in time, as I speak, Python is the most sought after programming language from the perspective of this machine learning, artificial intelligence, and many libraries are built on top of it. So it's a good time to invest some kind of money or your effort to learn this particular language and also the libraries associated with this. Okay, so with that, so there is a lot of difference with machine learning and or deep learning. As I told you, machine learning, whenever we say, let us say, what we wanted to do. So in a machine learning, let us say, simple example, let us take, we wanted to classify the images. Suppose if the images are given, so let us take the simple example. Most prominent example is the classification of an image, whether it is a cat or a dog. So how do we do? So like you take thousands of image and you actually train your machine showing those images and then telling them, look, this image is nothing but a cat, or this image is nothing but dog, or this image is nothing but animal. Okay, so for that, what we need to do in machine learning, we have to extract the features. That is called as the feature extraction. We have to extract the features. What are the different features? So how it will it classify? Suppose if I want to classify a simple digits also, how is it going to classify a digits? Okay, how 1 is different from 2? How 2 is different from 9, right? So that is what we have to have, what is called as the feature extraction. And then we extract the data, and then we extract the feature, and then we basically fed this feature to the algorithm, some kind of an algorithm, and the algorithm is going to predict whether it is a car or a not car. Okay, this is what is the output. So that is what we do typically in the machine learning. Whereas in case of the deep learning, so there are feature extraction and classification. Okay, that goes hand in hand. And then, so in this, basically what we are going to do is we are going to use multiple layers to extract the feature, and then build the classification model. So what is that and all, I will tell you in a while so that you can understand it in a better way. So this is what we will be building, what is called as a multi-layer neural network in case of the deep learning, to solve the problems. Many of the problem may not be solved with just directly with the machine learning. So then we will be going with the deep learning. Okay, so let me just pause for a minute. Hope you are able to get this. Okay, so if you have any doubts, you can put it in the chat window. Later on, we will keep some time to discuss this. Yes. Okay. Yeah. Okay. So let us understand how and what are the different types of neural networks. So the first one is the artificial neural network, or we call it as ANN. And then there is a convolution neural network, CNN, and then recurrent neural network. There are three different kinds of neural networks. One is the artificial neural network, and then the convolution neural network, which is based on the convolution function, and then the recurrent neural network, where it has the ability to memorize something and then use it. That is called as the recurrent neural network. Each one of them is used for a specific scenario. So let us start with what is called as the artificial neural network and how it is going to work. So there is a difference between them, and that we will come back later. First, let us understand how this is going to work, and then we will see how this deep learning would be helpful. So let us take this simple neural network. So what is this task? We have a task. The task is, so this is one animal called koala. So this koala, this animal is available in Australia. It is somewhat like our cat, but exactly not so. So let us say, as a human being, we wanted to, if we are given so many animals images, we want to know like whether it is a koala or not. So as a human being, just if we look at this and then we try to quickly say in no time whether this animal is a koala or not. But typically what happens probably inside our brain or inside our neural network, neurons, that is what we try to break further. That is what we wanted to do. So what is this we wanted to do here? The simple task is to identify whether this, whenever images are given, to identify whether this particular image is of this animal koala or not. Okay, that is what is the question. So now how do we go about solving this, or how do we go about solving this? Okay, so let us say there is this guy who gets his people. So there are many people, many of the people in the company, and he start explaining the feature of each and every part of the koala. Maybe it's eyes, okay, maybe it's nose, maybe it's lower part of the body, legs, and all. So he start basically showing the images of this to many people here, and then making them understand this is how a koala's eyes will look like, this is how the koala's nose will look like, or its ears will look like. Okay, so this is what he starts. That is what exactly precisely happen when we start this thing. So here what happens, if I show a particular image of this thing and this guy is concentrating on the koala's eye, when he looks at this, see, this is a lion, and he gives some weightage. So he gives some weightage to this, and then he will say, no, he gives the weightage of 0.03 as far as the eyes is concerned. Okay, and this guy gives a weightage of around 0.1 to this when the images is shown to them. So if the higher weightage means, so it is approximately matching whatever they have learned, right? So here what happens is we are going to build a system like this. So here what we have taken many people here, and this is what we call in terms of the neural network as the input layer. There are many people, and each of them is given a specific task. Each of them is given a specific task, and they are expert in analyzing some of the parts of the koala. And once they analyze, they will get it. They will take them to their supervisor, and supervisor, this Sarina, she's good at identifying the face of the koala, and this Nidhi, she's good at identifying the body of a koala. And they put them together, and they come to this guy Sergey, who is an expert in telling X, your analysis, image analysis is quite not on fine, and this we call it as the output layer. And finally he says, yes, this is a koala or not. So this is what we call it as the layers. As I told you, like human brain is a complex system where we have multiple layers, and the multiple layers are put like this together when we try to identify an animal by looking at that particular animal. This is how it happens. So now let us look at this. So then once this guy, okay, they start giving the weightage. So these people are expert in, say, eyes, and someone is expert in nose. He will give, if we show the image and he is going to break, that is what we call it as a feature. What is a feature here? Feature is nothing but each one of them is a feature. Like eye is a feature, nose is a feature, ear is a feature. So here what happens? Like this guy Mohan, he's Mike. He is given a task of identifying whether this is the koala's eyes. Okay, and then Mohan is given a task to identify whether it is a koala's what you can call it as a nose, and then this Saqib is given a what you can call it as a ears. So what they do, when the image is given, they will look at that specific part only, and they try to give a weightage. The weightage starts from 0 to 1. Okay, these are the feature. What are the features? Here, eyes is a feature, nose is a feature, ears is a feature, and then going to give the weightage. So this guy says, okay, eyes weightage is 0.2, nose is 0.5, and then ears something. And this Serena, what she does? So she uses all these things and she calculates and she tells, yes, this is a face or not a face, right? So this is where the image recognition happens in different layers. So that is what we do in a neural network. So in this way. So now let us look them together now. Now these are the people now ready to, now they are trained to do this particular task, and now they are ready. And when the image is given, they start working on the image. See, now we are given a different image. See, now the collar not necessarily it should be sitting like that. It would have tilted its face. It would have like climbing up. Still, they should be able to recognize whether it is a koala or not, right? So this is what they have to do. So it may be image may be tilted, image may be scaled or things like that. Still, they are able to. They should be able to recognize this. Okay. So this is how a multiple layers is built. Multiple layers is built. So as I told you, like in case of the neural network, we will be using identifying different features, and for each feature there will be weightage, and then we would be summing all the weight and the feature and then coming up arriving with some calculation, and we will be using something called as an activation function. So what is the activation function? As a human brain, the each neuron is connected, and when the neuron passes some impulse, some message from one to another, it activates the other neuron. So that we call it as the activation function. So here also we'll be using some activation function so that it passes the output to the other neuron, which becomes the input for the other neurons to further basically understand and analyze this, right? So this is what we call it as the neural network. And then there are so many activation function. So basically some of the activation function converts this linear thing into a non-linear thing. Like there are some activation function we will be using that we will be seeing in the next class, next session. Like one of them is a sigmoid function. So what is a sigmoid function? Whenever we pass the information, whenever we pass a value to this, it is going to convert that value between 0 and 1. That is called as the sigmoid function. Similarly, there is something called step function, tanh, ReLU, and all those, right? So these are few of the activation functions which we'll be discussing. And now let us come back again here. How is this activation neural network? Let us say I have this set of data. I have set of this data. This is the data we have. We have collected from a online campaign or something, or some insurance company. And only one feature we have, which is age. And we wanted to know whether that guy has bought the insurance or not. Okay, there is only one feature, which is the age. And what is the outcome is like whether they have bought the insurance or not. So we have given this kind of data, and we train the machine to identify whether that guy is going to buy a insurance or not. And if I come up with some new set of data, it should be able to predict whether this guy will be able to buy the insurance or not. Okay, that is what is a problem we try to solve. This is one of the problem that is solved by the deep learning, that is the predicting something. Okay, in this case, predicting the person will buy an insurance or not. This is the data set. So usually what you can do is you use a what you can call it as linear regression, linear algebra. If you remember olden days, like golden days of your high school mathematics, where you use a linear regression. And what we are going to do, we are going to use this, and we try to plot this graph like this. Okay, these are all the various points. So the person at 20 years, mostly youngsters don't buy insurance, right? As you grow old, they feel the necessity for insurance or for their parents. Okay, that is what they are going to buy. Suppose if I try to draw this, and this is the x-axis as the age and y-axis as the, what you can call it as the insurance, and 0.5 is the threshold. So if the probability of something is going above 0.5, that means they are going to buy it, or not, they are not going to buy it. So if I try to plot a graph, this would be like this. In case of the linear regression, y is equal to mx plus 3, I want to draw a best fit line. But if you draw a best fit line, the problem is like there may be few of the data points. So which even though these people have bought the line and bought the insurance, but this line is not able to predict that whether this particular linear equation may not be able to predict whether they have bought an insurance or not. So that's why, and also there are some outliers. Suppose if let us say one more person age 85 buys the insurance, then your entire line will go off, and then it will predict something wrongly. Suppose that previously these people have bought the insurance, as our linear regression moves further, so it may predict these people have not bought the insurance. So that's why what we do is we try to use rather than a linear equation, we are going to use what is called as the non-linear, and this we are going to use what is called as a sigmoid function. So when it comes to machine learning, very few of the things you need to learn is the statistics, and another thing you need to learn is linear algebra, differentials, differentiation, bit of calculus, and all those things are very much essential. So here, instead of this may not give us the best fit, then we are going to use what is called as the sigmoid function. Okay, so this will probably fit most of the lines like this. So with that, what we do is we can use some sigmoid function. What is it? Is just a function. It is like any other function, any other equation, right? So what it is going to do is this function is going to convert any particular value between 0 and 1. That is what we wanted to know. What we wanted to know here is whether the person is going to buy the insurance or not, right? So that is what they wanted to know. Then we are going to use this sigmoid function, and where this is a Euler's number minus z. Suppose if the value of the sigmoid is higher, positive, then it is close. This value z will be close to 1. If it is negative, then it is close to 0. That means it is going to give us a value which is between 0 and 1. So we wanted to know whether a person is going to buy the insurance or not using this kind of a function. It's called as the activation function. Then what we try to do is we try to superimpose. So we use this first linear equation, which is y is equal to mx plus c, and then we feed this y to here. So what is m and x? See, x is the feature here, right? M is the slope, and then v is the intercept, right? Here feature what we are using is the age. So your equation may be complex. So here it is simple because I have only one feature. So then we are going to use this z, and that's what we are going to convert this linear into a non-linear, and we will be getting this 0 and 1, which is nothing but it looks like a neuron. This is what the two-step process. What we do is we are going to feed in the feature. Okay, the feed in the feature, and then we are going to apply this particular equation, and we will be calculating the slope and the intercept, and then we will be getting the output. So here, if the value is lesser than 0.5, means the person is not going to buy the insurance. If the value is greater than 5, means is going to buy the insurance. So this is what this looks like, a neural network, right? So it is nothing but suppose what if I have many features? Like what if it is not just the age, right? It is the income, education. Based on that, whether a person is going to buy the insurance or not, right? So our equation becomes complex when we have so many features. And then we wanted to calculate y. It is nothing but summation of wi xi, where we call wi as the weight and xi as the feature and p is the bias. So this is how the equation would be derived. And if you look at this looks like a neural network. Okay, this looks like a neural network. In case of a neuron, like these are the various what you can call it as information which is passed to a neuron. Okay, which is passed to a neuron, and it has features and it has weight. What it is going to do is it is going to calculate the summation of the weight and the weight and that particular feature with the bias, and then you pass this information, then it is going to give an output to the other neuron, which is nothing but using some functions. In this case, it is a sigmoid function. So this looks like a neural network. So that is what we try to simulate, and then we try to go ahead and start doing this. Same thing happens with the image classification also. When we want to get the image classification, same thing happens. So this is how our brain has multiple neurons with many inputs coming into it. It processes something, it gives an output that becomes an input to the other neuron, and it continues. And set of neurons gets activated when they want to do, or when they want to identify something. Like suddenly some file catches up, then suddenly some neurons get activated, and then it informs us to do some kind of an action, right? So that is what we will be doing using this neural network. Now, coming back to this, let us say we wanted to identify the image. Like suppose I have a set of images, and like the images of the numbers, like handwritten images, like 1, 2, 3, 4, 5, up to 9. So there are thousands of images, and I want my machine learning or like deep learning algorithms to identify whether this particular image is 1 or 2 or 3 or 4, right? So then what we do is we use the inputs. This is the input layer. And in this case, a simple layer, like what is called as a perceptron. So this is the input layer, just the output layer. There is no hidden layer in this case, just the input and the output. So what it is going to do when it is going to get these features. What are the x1, x2, x3, f4 here? Maybe a horizontal line, maybe a straight line, maybe a vertical line. So these are all the features. Okay, these are the features we feed in. And then it is going to say, like, look at this. So this particular weightage 4. So it tells 4 is 1, right? Okay. So this is how most of these neurons are densely connected. We call it as densely connected, and then it is going to basically identify this thing. So these kind of things we can do with the image classification and all. Okay. So let us take some practical example how it is done and all, just to give an idea, not to demo, not to like make you what you can call it as perfect or something like that, just to give you an idea how this can be done. So just I will show you one of the sample demonstration on this. So for this, what are the things required? What are the prerequisites in order to do that? So you should have Jupyter notebook. And basically, you can get it when you install what is called as Anaconda. Anaconda is a Python distribution. Okay, you can download Anaconda from the net. You can go to the net and you can download. When you download the Anaconda, then you will get the Python also. So you can say download Anaconda, or whichever the operating systems. You can go and you can download the Anaconda. So when it's all free, like you can download and you can install. When you download and install it, it gives you a lot of tools. Like, see, this is where you can download it. So you can download it. So download this based on. So here this Anaconda with version Python 3.8 implementation is available. You can download and you can install. When you download and install, it downloads many of the libraries required for the machine learning. So that is the way. If you just download a Python, then you have to install many of them like pandas, numpy, matplotlib and all. But these are all available as part of the Anaconda distribution. You need not to install again and again. So here in this, what I would be doing is, along with this, it comes with Jupyter Notebook, which is like graphical user interface, where you can run this line by line program and then see the output. And then we will be using what is called as the Keras. Okay, so this is one of the library which is used in deep learning. Okay, so Keras, that is what we are going to use. So if you if you open this Jupyter notebook, so the opening the Jupyter notebook is just to, if you install them, and then once you install all the required software, and then if you check the path, everything properly, then you can just say Jupyter notebook. Okay, if you do this, then if everything is fine, it is going to open the Jupyter notebook like this. Okay, so when it opens the Jupyter notebook, you can get started with writing, started with a Python program. Okay, like this, and just we will say print. And then just you can run like this. Okay, so this is how we are going to execute. So today what I would be showing is this a pre-programmed one because of the lack of the time in 1 hour. So just I will try to explain what is this, how we are going to do, and also it is going to take some more time when we go with the deep learning, because a lot of images are there, and we wanted to understand the each step. So here, what is that we try to do? We try to use the handwritten digit classification using neural network. There are a lot of handwritten digits. Where is these digits? Okay, so this is available in this data is available in a library. So that is in the Keras data set. Okay, we have this MNS. Okay, in this load data means it has a lot of handwritten images, like 1, 2, 3, 4, like that. Handwritten images are there. So what we are trying to do here is we will be actually using those images, and we will train our machine on the, we are going to divide the data into two parts. One part is called as the training data, another part is called as the testing data. In case of the training data is used for the training. So more and more training we give, it is good, like so that the machine can understand in a better way. So this data we are going to divide into two parts. One is the training data and the test data. And then we train the model. And then once we train the model, and then we are going to test the model whether it is working fine or not. Like it is like you are preparing food, right? You are preparing the food. So every day you start preparing the same food, maybe the 5th day or the 6th day. So you can test it, okay, whether the test is proper or not, something of that sort, right? So this, we will be using these libraries, TensorFlow, and then TensorFlow, it has Keras, and then Matplotlib for visualization, and then NumPy for what you can, it is a numerical Python that is used for array manipulation. See guys, finally it's all mathematics. So any image is stored as a matrix, right? So it's all zeros and ones. So that is what we should be knowing this. So here what we are going to do, just we are importing the library, and then after importing the library, we are going to basically divide this data into train data and test data. And if you look at this, we have around 60,000 images for training purpose, and it's already available. And then the testing purpose, we keep only 10,000. Training purpose, we keep 60,000. Then you can see like this is if you see the shape, it's a 28 by 28 matrix. So this is stored, this image, I mean the each image like 0 or 1 is, it needs 25, here in this case 28 by 28 matrix. Okay, this is a big matrix, right? So if I want to see the matrix of 0, that means the image of 0, see this is stored like this. In mathematically it is stored like this. See here, it's stored like this, the 0, and you can see here these are the values. Say this is a, if you are using a grayscale image, gray image, like these are the values, like 18. So this is where that image 0, like some of the portion only will be highlighted, right, in the 0, other portion will be empty. So it stores it in a matrix like this. And then if you look at this, this is how the image is there. And then if you look at the, use the matplot and then see x train of 0, that means I want to see the image 0. The image zeros, I mean the image at the position 0, this is like this. Okay, this is the image 5. Okay, then you can check whether is it the image 5, because these are all label data, we call it as the label data. So this is what we do. And usually in order to bring the uniformity, what we do is we divide each of this number by 255 so that I will convert them into 0 to 1. So that is what we do. And then we start, the next thing is we have to flatten the data. So we have to flatten the data means the multi-dimensional, this thing, the array we have to convert into single dimensional. That is what we call it as a flattening. Flattening is converting in the multi-dimensional array into single dimension. That is what we do here. We call it as the flatten. And this is where we are going to reshape it. That means I want to convert this into a single dimension. So that is what totally we will be having 784. Okay, this is the flattened data. So first, if you see, look at the flattened data of the 0, this is how it will be. So this is a 784. Okay, data having 784. So this is how, like, this is represented 28 by 28 grid. See, 2 means, see, some of the portion, when I try to draw 2, like, see, some of the, most of the portions are 0 because nothing is there. Only few portion, like some is 87 to 40 and all. So this is what is highlighted. This is how the 2 is represented mathematically. Then we put this into a, this is a flattened data, and we are going to put it into a, what you can call it as the model, and then finally the model is going to predict what is this value by looking at the features. By looking at the features, it is going to predict, and then we will be checking whether my model is. So here we are going to build a multi-layer. See, as I told you, like, we are going to drive multi-layer. Here we have what is called as the input layer and the output layer. What is the input? Input is 784. In this case, I have an output layer. Output layer is 10. 10 means what? Like only 10 digits, right? 0 to 0, 1, 2, 3, 4 and all. And we will be using function, sigmoid function. Activation function is a sigmoid that is going to convert this linear into non-linear, right? So any value you feed in, it is going to convert into a 0 or 1. Okay, so here we use some, once we build a model, and then we are going to compile that model using some kind of optimizer. Here we have Adam optimizer and loss function. Again, we are going to talk about this in the next webinar, and then we are going to fit this model. So this is what we do, model fitting. Or building a model is, this is where we are going to put this train data, flattened data, X train and the Y train, and then we are going to iterate it. We are going to run it for 5 iterations. So different iteration we are going to do. Each iteration, our prediction will improve. There is something called loss function, and then our prediction is going to improve. Accuracy is going to improve of this until we start evaluating. We want, now the new data is given and we want it to predict what is this particular data. Suppose if I get the new data, we are going to predict it. Okay, and then we are going to show what is the predicted value. So in this case, the predicted value, and we will compare whether the predicted value and the actual value is fine or not using something called as, you can use the heat map. Okay, and then there is something called as truth function, and this is the matrix, and this matrix will help us to tell how far the machine has predicted properly or not. Okay, so this is called as the confusion matrix. It is going to help us to tell how far it is. See here in this case, we have 0 image 0 is predicted properly 971 time. Okay, 971 time. The truth is 971 time, and then predicted as 0 as 971. But there are truth is true. Okay, but it has this is predicted as 4. Okay, so like this, there will be it is not that any machine learning algorithm we use like it will be 100% accurate. There will be some kind of error. So it is our we have to see like how we can overcome that, and then how finally we try to achieve the required target. Okay, so this is just a glimpse of what is called as the neural network, and then just I wanted to explain you how do we use the neural network to do this thing. So in this case, it is a handwritten digits. So just to look back at this is what we are trying to build multiple layers. So here just we have one input layer and the output layer, and there are so many hidden layers. As I showed you in the example of a cola, like there will be hidden, there could be multiple layers here. So each layer is going to extract a particular feature, and then that is passed to the next layer and things like that. Okay, so that is how this is going to work. And again, the basic requirement for this is a Python programming language and some of the practical associated with that particular programming language, and bit of data science like pandas, matplotlib. These are all prerequisite if you want to get into a directly into the deep learning. Okay, so many of the problems nowadays in real world, they're using the deep learning to solve it. So this is very much essential, and many of the companies started working on their product or services. And nowadays, you see, like there are many things coming as AI enabled, right? Everything they wanted to AI enabled. So this is just an introduction. Hope I have covered this agenda. Just I introduce you to what is AI and what are the applications of AI. Why should you learn AI? And just introduction to neural network and hands-on using the ANN. So hands-on just to show you like what kind of programming you can do with with using a simple digit classification. Okay, so with that, let me conclude my session, and let us me see you have any queries, and let me see how I can answer. Okay. Yeah. Okay, let me see what are all the queries. Do you have any material use cases for media digital marketing analysis? Yes, we do have. Yeah. And then how is it different for predictive analytics? I heard. Okay. There are some questions. Any good books you can recommend in the subject? Yes, definitely. Please join my other two sessions. Definitely, I would be giving you. Do you have any material use cases? Yes. Okay. And then share the presentation. I cannot share the presentation, but as Naveen told, it is a video is that. Okay, you can go through the video. Video will be recorded. Video will be shared. Okay, the code sharing. Code sharing. Okay, let me see. Just a minute. Just a minute. Okay, data set sample. Yeah, this thing I think I will check with Naveen and how we can share it. Yeah. I suggest you people to join next two sessions. Definitely, we will be working on this. Often hear that before taking up any problem, first we need to check if the reality really required to apply ML, it will be solved with using normal approach. How exactly we can figure it out with the ML problem or not? Yes. See, the thing is like not necessarily like every use case is a fit for ML. Okay, so it depends on what you try to achieve, right? So if you have huge data, and if you feel like you want to build a model which could help you to solve some kind of the business problem, then you can go ahead with the ML. But otherwise, like we have to like there is a data analysis process, right? So what is that problem we are trying to solve? So it all depends. It could be sometimes it may be simple statistics may solve a problem. Then you're not necessary have to go with the ML. So flattening is same as unnesting in SQL. Yes, yes. Neural network refers deep learning, okay, or the same. See, neural network reinforcement learning is a bit different. Reinforcement learning is like on the go you learn. Like it is somewhat similar to drive self-driven car or playing a chess. That is called as the reinforcement learning. Neural network and deep learning, they are all part of the, as I told you, this is part of the deep learning. In case of the machine learning, there are three things. One is the supervised, unsupervised, and the reinforcement machine. Okay, so mostly the supervised and the unsupervised, this thing are part of the what you can call it as the deep learning. Okay, so the reinforcement learning is a bit different. What is the input and the output layer means? So input layer is like where we give the input as a feature. Output is, in this case, it is a classification, whether it is a whether it is 0 or 1 or 2. What is that out? Finally, the final classification is the output layer. Input is the features which we feed into this. Do we need to derive these formulas for each and every scenarios? Not necessary. Like there are a specific kind of activation function you have to use for some of the scenarios. So we have to use, and also again, it is on a trial and error basis, and you apply this various function and see which one will give you the good result. So how do you assign the weightage to each feature? Again, it is trial and error basis. Okay, so you can start with some value and see the last function. If the last function is more, you try to give the give different weightage. Okay, so that is what we do. So this is called as the back propagation. When we do the back propagation, that's what. No, no, no. Is Z a same score, Z score? No, no, no. That is different. Here just a then just Z is used as a symbol, not the Z score. So M and B has, like someone has asked, what is the so M and B? M and B is like it is a linear regression where B is the bias and M is the slope that can be calculated mathematically. Okay. Again, there are different activation functions that could be used in various scenarios. So you can attend rest of my webinar where we can discuss something. How does the data is loaded to the AI for data analysis? Again, most of the times data is in the form of a CSV file or a Excel. There are libraries associated with Python where you can load this data. Like Pandas is there, or there are built-in data sets available. Okay, so thanks for your participation. And so can we use R language instead of Python in machine learning? You can use it, but Python is a generic programming language. It has its own advantages. You can further use it for web application development. Further, you can use it for like data analysis and everything. Like R is very specific to this, but Python is more generic. You can even do Internet of Things using Python. So that's why it's more generic. Okay. So good to see the lot of interaction happening, lot of questions being asked. Okay. Again, thank you very much, and please join next 2 days webinar tomorrow, day after, and it's between 3 and 4, and hopefully we can further discuss on this. And I think this session was useful to you. Okay, and hopefully this has given you at least an insight into what is deep learning, how to do it, because a lot of things are there. Hopefully this is okay. Thanks, Shivani. Thank you. Great session, though I do not have a lot of technical Python, but could understand some of the basics easily. Yeah. Okay. Okay. Thanks a lot. please attend tomorrow and day after tomorrow session. Okay, so with that, we can conclude today's session. And as Naveen said, a mail will be sent. In that, you will be having the link of this particular video. So wait for some time, you will be getting the video. Please do join back for tomorrow's session. Okay, thank you.